Hi, welcome back. We're continuing to talk about logarithms. In the last video, we looked at how to evaluate a logarithmic expression, and this worked out really well when we were able to get the same base. But what happens when we have something kind of ugly, like log base 2 of 5? So log base 2 of 5 is equal to x. So this is saying 2 to the x is equal to 5. We need a little bit more advanced methods to solve this, which we will be getting to shortly. But for right now, I want to be able to approximate this. So I'm going to take a look at the number 5. So 2 squared is 4. And 4 is less than 5. And 2 cubed is 8, which is greater than 5. So I know that 2 to the x is somewhere between 2 cubed and 2 squared. So that means x is somewhere between 2 and 3. And I don't know exactly where, but that means this is going to be about 2 point something. I don't know exactly what, but somewhere in the 2 to 3 range. So I can get fairly close to this. I can get kind of an order of magnitude or even a little bit better. I can get pretty darn close. So looking at 3 to the 40, I'm going to go through the same process. So I have 3 to the x is equal to 40. So looking at 40, all right, 3 cubed is 27. And 3 to the 4th is 81. So that means that 3 to the x is somewhere between 3 cubed and 3 to the 4th. So that means that x is going to be 3 point something. I don't know exactly what, but I can get kind of the within 1 of what it is. So if we have a logarithmic expression 2 to some number or log base 2 of something, and it's not going to work out perfectly, I can get approximately what the answer is, not exact. And the reason that I'm talking about this right now is this is just to say that a logarithmic expression is just a number. It might be a positive number. It might be a negative number. It could even be 0. So if I was looking at log base 2 of 1 is equal to something, 2 to what exponent is equal to 1? Well, that's got to be 0. 2 to the 0 is equal to 1. So this logarithmic expression is just a number. And that number might be a nice, pretty integer value, like it was in these two, or it could be a rational value, or it could be some decimal value that I can't quite get by hand, but I know it's somewhere between 2 and 3.